Welcome to the online lecture series on power electronics. In our recent lectures, we discussed about DC-DC converters, and then we concluded the design of an inductor, that how we can practically design an inductor, the parameters that will be needed to design an inductor in lab. And now we are going to discuss about AC-AC converters, or you can say AC-AC control. So let us move toward our lecture. AC-AC converters are basically relatively easy as compared to DC-DC control. In DC-DC control, we needed to find filtering as well, filtering values, the type of filter that we need to use, the switching rating and switching frequency and similar things. But AC-AC control is relatively easy and simple to understand. An AC voltage controller is a converter that controls the voltage, current and average power delivered to an AC load from an AC source. It is similar to that DC-DC control, in which we were controlling DC voltage or DC power voltage or current from a DC source to DC load. And in this AC-AC control, we are studying the control of AC to the load. Just as we were using electronic switches in the DC-DC converters, that we were adjusting some specific or we were determining some specific duty cycle, and on the basis of which we were determining the average value of voltage or output to average output voltage or average output power. So the same case will be here in the AC-AC control, in which electrical switches will be used to connect and disconnect the source and the load at regular intervals. But in DC-DC converters, we needed some other additional inductor and capacitor as well. But in this case, the only things that we will be controlling are the switches and their duty cycle. In a switching scheme called phase control, switching takes place during every cycle of the source, in effect removing some of the source waveform before it reaches the load. So we are already familiar with this type of conversion. Basically, these are the this is similar to the thyristor control, in which we were controlling the phase of the thyristor. That is, we were firing the thyristor at a specific angle so that we can obtain a part of sinusoid at output. And another type of control is integral cycle control, in which the source is connected and disconnected for several cycles at a time. The phase controlled AC voltage controller has several practical uses, including the light dimmer circuits and the speed control of induction motors. The input voltage source is AC and the output is AC, although not sinusoidal, because we are obtaining a part of sinusoid, not the complete sinusoid. Therefore, this kind of circuit is classified as AC-AC converter. Now, the single phase AC voltage controller. A basic single phase voltage controller is shown in this figure 1, where you can see that we have a source voltage Vs sinusoidal, two anti-parallel switches S1 and S2, these are thyristor switches, and some load. This type of arrangement makes it possible to have current in either direction of the load. When switch 1 will be operating, the current will be in this direction, and when we will be talking about the reverse polarity, this in that case S2 will be operating, and when we are talking about this polarity, in that case switch S1 will be operating. A triac is equivalent to the anti-parallel SCRs. These are the waveforms of a AC-AC converter. This is the source voltage Vs. It is complete sinusoidal waveform. This is the output current I0, and this is the output voltage V0 that will appear across the load. So you see that when this thyristor was triggered at some specific angle alpha, in that case the output voltage will try to follow the input voltage Vs, and a part of sinusoid has been delivered to the output. And similarly the second switch will be then fired at pi plus alpha, and it will conduct from pi plus alpha to 2 pi, and similarly the cycle will keep on continuing. I0 and V0 are in phase because our output load is resistive in nature. VSW is the voltage that will appear across the switch. So when the switch is in off condition, in that case some voltage will appear across this switch, and when the switch will be in on condition, in that case there will be negligible voltage drop across the switch. So some waveform like this will be appearing across these switches.